Well, first, welcome to Introduction to Meteorology here. I thought I would just start out just giving you a quick look at the weather today. What we have here is a satellite image, and on top of that is overlaid lightning flashes. So, if you're living in the central part of the United States, we have a pretty good low pressure system out here, the trailing cold front down through this area. But what I really wanted to just show with that as well, you also have the lightning down in parts of Florida there. And also you have clouds you can see across the Gulf of Mexico. These are all boundaries in the atmosphere, places where there's a contrast in air mass. Notice there's hardly any clouds across Texas and parts of the South. There's a lot of clouds across the northern part of the United States, more typical of where low pressure systems move. We're going to talk about lows and extratropical lows. So if we look just at today's weather map, what you find here is that low. Here's the low over Iowa, Wisconsin, Minnesota, dropping south with a cold front through it, and relatively cool air for this time of year. Temperatures are in the 60s and 70s out here, which for mid-August is kind of cool. We have a warm front extending east. You notice there was a lot of clouds and everything across parts of the Ohio River Valley into West Virginia. That's all right along this stationary boundary here. So you can see the fronts, the low pressure systems all play roles. High pressure tends to give you nice weather. Low pressure tends to give you bad weather. And when you combine them with satellite image, you get a little bit more detail. Maybe where lightning and thunderstorms are occurring. Maybe you can look at cloud tops or temperatures. Even moisture you can see on satellite where it's moving. So all things we're going to discuss in this course. So let's just get into a little bit of the introduction here. Really, in order to understand weather, you've got to be able to monitor the weather. So to look at the weather, you notice I showed you a weather map of the surface. All those dots on that map are observations. Each one of those observations was taken at right around the same time, within a minute or two of each other. That is the only way we can actually describe what is happening to the weather right now. That's why it's all done that way. So weather is what is occurring here and now. Meteorology is the study of weather, processes that cause it, life cycles of weather systems. Climate's more long-term. In climatology, it's basically the whole Earth system, how it impacts climate or our weather, the interactions between it all. So in order to get all the observations at the same time, in other words, say I wanted to take an observation at 7 a.m. Eastern Standard Time. Now that would mean that the same people out in the West Coast would be taking that observation at 4 a.m. their time. So you can see here, we want all these times to be uniform. So we want that observation, which at 4 a.m. represents exactly the same time as 7 a.m. in the Eastern time zone. So that's why we want all the times to be exactly the same. Interestingly, meteorologists use universal time, basically Greenwich Standard Time. So we look literally what the time is over there and work all the observations around the world are based on those times. Here are the fronts. I just showed you those. Notice the high pressures tend to have nice weather. Low pressures tend to have bad weather, and fronts bring stormy weather with them. High pressure has clockwise winds. Low pressure has counterclockwise winds. You're going to see a lot of that in this course. Why? that occurs, we're going to learn. Air masses, they're huge areas of the same type of air. Think about it. If you had air sitting over the Gulf of Mexico into the Caribbean Ocean, that air is probably getting warm, humid, because of the ocean underneath it, very warm. That's a warm, humid air mass that comes out of there. It's a maritime tropical air mass. How about if one forms over Canada? Well, there's not a lot of moisture up there. It's pretty cold usually. So that's actually called a continental polar air mass. Basically has hardly much moisture with it, and it's quite cold. When they come out of the Arctic, we get the Arctic air masses with them. And where these air masses meet is where the fronts are. And that's where you have your cold and warm fronts. Cold front just means the cold air is advancing. It's moving forward. Warm front means the warm air is advancing. It's what's moving. Now, warmer air always will ride up over cold air. So that's why when you have a warm front coming, you get the clouds and all ahead of it. The actual warm air has moved into your area aloft above your head before it actually reaches you at the ground. However, on a cold front, they're very steep. The cold air pushes that warm air out of the way quick. You wind up with, many times, thunderstorms or very heavy showers. If I ask you to describe the weather to me, what your weather was outside today, I'm sure I get a variety of opinions. I bet one of them, most of you would talk about temperature. What's the temperature? Another one might say, boy, it was really humid today. Maybe you want to know if it's the precipitation or raining. How about clouds? Each one of those is an element of the weather that you're going to learn about, how they work together, and how we forecast those. Air pressure. Believe it or not, air pressure is very important. We're going to talk about air pressure and winds. Some days you probably don't care about the wind because there's not much. Other days it might be blowing really hard. And you really care about that wind. Here we talk about clouds. We're going to talk about cumulus clouds, or relatively puffy clouds in the sky. Cirrus clouds are ice, basically little fibrous clouds, very high up, very cold clouds. Fog is basically a cloud in contact with the ground. And stratiform clouds, basically they're horizontal clouds that are all about the same level. And they look like sheets, literally. And when you're looking out at thunderstorms, what they are is cumulus clouds. We talked about this cumulus clouds a minute ago. We put nimbostratus, nimbocumulus on them, cumulonimbus, to mean it's a thunderstorm producing lightning and all. And clouds move with the wind. And since the wind aloft moves in all kinds of directions, those clouds can be moving in different directions. Sometimes I'll just watch the sky above me and I'll see cirrus clouds moving one way, cumulus clouds moving a totally different direction. It's really fascinating to watch. So we got a little bit about this. We'll talk a lot more depth as we go through the course.